Let's start the half angle formulas. We were running out of time on the last video. And if you look on your unit circle with identities sheet that I sent to you, the cosine half angle formula looks like plus or minus square root of 1 plus the cosine of u over 2. So the answer, the plus or minus in front, is not that there's two answers to this. The plus or minus in there is saying, well, look where the angle is and find out if it's plus, if it's a positive or negative. Because we know that all students take calculus. If it's going to be in the first and fourth quadrants, it's going to be a positive, and if it's in the second or third, then it's going to be negative. So that's not that there's two answers, it's that you have to pick which one it is. So if I take, and since my answer is going to be negative, because if I do the half of this angle, I'm going to end up somewhere out in that direction. And that's a negative place, so I'm going to go 1 plus the cosine of the original, and we have the negative 1/8 all over 2, and if I take 1 minus, that's 7/8 times 1/2, which is the square root of 7 over 4, and we know that's going to be negative. Let me see if I can group this together and make it a little bit smaller so I have room. I should definitely put these on different slides because I'm going to run out of room on all of these. Plugging into the sine formula, again, we're going to have plus or minus the square root of 1 plus the cosine Oh, 1 minus the sine. Sine is the minus one. Minus the sine of u all over 2. Oh, jeez. Let's try that again. If I'm looking for the sine, it's 1 minus the cosine of u over 2. And let's plug in. We already know what the cosine is. So I'm going to say 1 minus, and that's negative 1/8 over 2, which gives me 9/8 times 1/2, which is the same as 9 over 16 square root of plus or minus, which gives me 3/4. And just to figure out, is the sine in this, because we're looking for this original angle, is going to make that a negative, because in the original is in the third quadrant, and the sine is negative there, so we get a negative 3/4. And let's make that smaller. And the last one here is the tangent. And so if I look at my formula, I'm going to have the sine of u over 1 plus the cosine of u. And we already know that the sine is the adjacent over the hypotenuse. So I'm going to say negative 1/8 divided by 1 plus the cosine of that angle. We already know is, opposite is the square root of 3 root 7. Negative 3 root 7 on top there. Sorry, somebody walked in the room and I was distracted there for a second. And so if I simplify this, I get negative 3 root 7. 1 minus 1/8 gives me 7/8, which is the same as negative 24 root 7 over 7. All right, let's take a look at this one. If we have x is equal to 5 sine of a, then x divided by 5 would equal the sine of a. And it tells me that it's in the first quadrant. And so we know that the opposite over the hypotenuse would be that, using my friend Pythagoras. I get b squared equals 25 minus x squared square rooted. So this side down here is 25, square root of 25 minus x squared. And if we are finding the sine of 2a, that's, the formula is on your sheet, double angle formula, sine of a times the cosine of a. And so I'm going to say the sine of 2a is equal to the sine of the sine, or 2 times the sine, and we know that the sine is x over 5, and the cosine is the square root of 25 minus x squared over 5. And if I do a little bit of simplifying there, I get 2x square root 25 minus x squared all over 25. That is your sine of 2a. Use the half angle formula to evaluate this, the sine, cosine, and tangent. So I know that the sine of pi over 6 divided by 2, and I can use my half angle formula, and I'm going to say, well, in the first quadrant where this is, it's going to be positive. And so 1 minus the cosine at pi over 6 over 2, 1 minus, and the cosine at pi over 6 is, cosine is the x, which gives me root 3 over 2, all over 2, which gives me common denominator 2 minus square root of 3 over 2 times 1 over 2. Instead of dividing by 2, multiply by the reciprocal, which gives me 2 minus the square root of 3 all over the square root of 4, which I'm going to write as 2. And so that's my final answer. Let's see if we can do the cosine of the same thing. And we get pi over 6 over 2. Green isn't going to be good there. So plugging into my formula, and again, first quadrant, I'm going to be positive. And I'm going to say 1 plus the cosine at pi over 6 all over 2. The cosine at pi over 6 is root 3 over 2 all over 2. 2 plus square root of 3 over 4. 2 plus square root of 3 all over 2, simplifying it. And let's see if I can make some room for a tangent. A tangent, so I'm going to do tangent at pi over 6 divided by 2, which is that pi over 12. Plugging in, I'm going to say that's the sine at pi over 6, 1 plus the cosine at pi over 6. And I get, we know the sine is a half, cosine is that root 3 over 2. And I'm going to get a common denominator on the bottom, so 2 plus root 3 over 2. And then I'm going to say 1/2 times the reciprocal. And I get 1 over 2 root 3. And just for the fun of it, rationalize it. I get the square root of 3 over 6. All right. I definitely paused there afterwards because I think I have something wrong, and I want to make sure that I don't leave it wrong. And I think I changed that 2 plus root 3 into 2 root 3 when I multiplied by the reciprocal. So let's redo that, times 2 over 2 plus root 3, which is different than 2 root 3. And I can still cross off that, but in this case where there's two terms in the bottom, I'm going to end up multiplying by the conjugate, which is 2 minus root 3, 2 minus root 3. And so I get 2 minus root 3 over 4, inside, inside, outside, outside go away because it's difference of squares pattern, minus 3, which ends up being 2 minus root 3. There we go. Sorry about that. Let's take a look at this one and see if we can simplify it out a little bit. We're going to prove the identity, and we know that the cosine of 3 theta. Now, I notice that there is a cosine of theta in both of the terms, so I'm going to factor that out into 4 cosine squared theta minus 3. And if I rewrite it as 4 times the quantity of 1 plus using this formula, so I'm changing the cosine into the half angle formula, or using that formula. And if I simplify it, better use another set of parentheses here. And, oops, there, not in there. Okay. And so I'm going to have, distribute that on top, 4 plus 4 cosine 2 theta all over 2 minus 3. A little bit further, don't want to lose that. And dividing everything by 2, 2 plus 2 cosine 2 theta minus 3. I'm going to put the 2 and the negative 3 together, so I get 2 cosine 2 theta minus 1. And right there is where I get a little bit of stumped action, because if I look at the double angle formulas, and I know that there are 3 of them, if I look at the middle one that says 2 cosine squared u minus 1, that's very close, but this isn't a squared, that's a 2 theta. So I have no way of simplifying that. So I'm sure one of you will figure it out, and I'll let you show it to the class when we have class on Thursday. All right, let's move on to the next video.